It's a chaotic region, sculpted by the glare of one generation of massive stars that's giving rise to the next.
The Hidden Universe Showcase explores exciting new results in infrared astronomy from NASA's Spitzer Space Telescope, with your host, Dr. Robert Hurt.
At first glance, you might not think that this 5th anniversary image from NASA's Spitzer Space Telescope would actually tell us anything about our own sun or Earth. But astronomers see this region known as W5 differently. Its strangely chaotic dust structures are like a work of art. But to astronomers, W5 is more than just a picture. It's a graphic novel, telling a story of how one generation of stars is helping the next to be born. The scientists who've been translating this novel for us are Dr. Lori Allen and her graduate researcher Xavier Koenig, both at the Harvard-Smithsonian Center for Astrophysics.
Well, most stars probably form in regions like W5, that is, massive star-forming regions in which hundreds or maybe even thousands of stars form at the same time. The W5 region is about 300 light years across, and that's about 100 times larger than the distance to the nearest star.
While it's filled with thousands of average-sized stars, it's the dozen or so stellar giants that are really calling the shots. Compared to our own G-type sun, these enormous O-stars have about 30 times as much mass. Moreover, they're about 10,000 times as luminous, and most of that light is in the ultraviolet. Yes, we are talking instant sunburn.
So the radiation that these O-stars put out, vast amounts of ultraviolet radiation, has a very destructive effect. It breaks up molecules and it destroys dust grains. And the stellar winds, these very violent, energetic stellar winds, sweep up material around that creates these large bubble structures that we see, these very large cavities around them.
However, denser areas take longer to clear, lingering as the material around them is swept away by the radiation and stellar winds. This sculpts distinctive pillars that, like accusing fingers, point out the stars that created them.
The effect of this, in fact, we find is also can be a constructive effect, that the material gets swept up and gathers up enough material that it can collapse into successive generations of stars. We're pretty sure that dense clumps of gas are likely to collapse under their own gravity, and that's how we think stars form. But if you give them a little push, like the O-stars can, with the energy that they're putting out and the expansion of these bubbles, the stellar winds they're blowing past, this can help the work that gravity is doing in collapsing these clumps down, and actually help to either speed up or enhance the star formation process.
We can see some of these baby stars inside the dense tips of many of the pillars.
In W5, we think we can trace 2 or 3 generations of star formation, starting near the center of the big cavity, where there is an O-star, which probably represents the first generation of star formation, and then working outward to young stars that are found inside this big cavity, and then further out to stars that are just now forming in the molecular gas on the rim of the bubble.
This kind of study would not be possible in visible light. Only infrared images can pierce the veil of dust to show the interesting bits.
Well, what's great about Spitzer is that it's looking directly at the wavelengths where young stars emit a lot of their light. So the easiest thing we can do is just go and look for the reddest objects in the image, which are picked out excellently in this image by their bright red color, relative to the more blue ones, which we think are slightly older. They've lost all their material that was around them when they formed.
Some of those young stars appear to be shedding their surrounding material before our very eyes. At 24 microns, seen in red, a number of smaller stars have dust tails pointing away from the nearby O-stars. These dust tails indicate ongoing destruction of protoplanetary disks by stellar winds. Indeed, Stars unfortunate enough to form too close to an O-star could well be stripped bare before having any time to form planets at all. W5 shows us how interconnected things can be in our own galaxy. Stars are born, reshape the nebula around them, and give rise to the next generation of stars. Perhaps 5 billion years ago, some long-gone O-star swept up the material that formed our own sun. And if it had been a little too close, perhaps our own Earth would have never formed, and we would have never evolved here to look up and wonder why. For the Spitzer Science Center, I'm Dr. Robert Hurd, reminding you there's a hidden universe just waiting to be discovered.
The Hidden Universe is produced by the Spitzer Science Center at the California Institute of Technology in Pasadena. The Spitzer mission is managed by NASA's Jet Propulsion Laboratory.